So we're going to look at some predicting of reactions today, where I give you the reactants and you can tell me what the products of these reactions are going to be. So first up, we're going to look at synthesis or combination reactions. So I should be able to give you two elements and you can tell me the product that's going to be made. Specifically, I can give you a metal and a nonmetal and you can tell me what the products are going to be. For example, we have looked over and over again at the reaction when I take sodium and combine it with chlorine, I get sodium chloride. So if I take lithium and combine it with bromine, I'm going to get lithium bromide. So nothing too earth-shattering about that. And if I look at the second example here, aluminum and oxygen, I'm going to get aluminum oxide. And if I combine potassium and sulfur, then yes, you are correct. We're going to get potassium sulfide. So is that it, you ask? And yes, pretty much. But of course, we never miss an opportunity to write correct formulas and balance reactions. So that's what we want to do here. So the symbol for lithium is Li, and we react it with bromine, which is Br2 because of Hofbrinkel. And the formula for lithium bromide, I need to check my ion card or notice the patterns on the periodic table. Lithium in group 1 is a +1 ion. Bromine and all the halogens become -1 ions because they are one electron away from being like a noble gas. So the formula for lithium bromide is LiBr. +1 -1 cancel each other out. And then being good chemical accountants, I notice since there are two bromines going into the reaction, I have to put a 2 there to make two bromines come out. That also makes two lithium, so I have to come back and fix with that. And so now we have the complete balanced reaction of when lithium and bromine combine. I'll leave those other two for you to try on your own and give you the answers later. Decomposition reactions are the reverse. And so again, there's a limited type of reaction I can give you. I can't give you some crazy complex reaction that you don't know how it's going to break down. But these are all binary compounds. If you remember from our flowchart, binary compounds mean that they're made from two elements. So when I see zinc nitride, I know that this is going to break down into zinc and nitrogen, the two elements that make it up. Likewise, magnesium oxide, you guessed it, is going to break down into magnesium and oxygen. And carbon tetrachloride is going to break down into carbon and chlorine. And so yes, it's just that simple. But again, we do want to practice our equation writing. Zinc nitride, I have to look up on my friendly ion card. Zinc is always +2, even though it's a transition metal. If you look on your ion card, it's the third chart down. Zinc is always +2. Nitrogen, a representative element at the top, is always -3. It wants to gain 3 electrons to be like a noble gas. So because of that, I'm going to need 3 zincs and 2 nitrogens, crisscross. All right. And that's going to break down into zinc, which is Zn, and nitrogen, which is N2, Hofbrinkel. And so to balance this, nitrogens look good. 3 zincs are going in, so I have to put 3 zincs coming out. And so you can try those other two and finish those other two off, and then I will give you the answers to that. The last ones we're going to look at here for today is combustion reactions. Combustion, the ones that we look at, involve a hydrocarbon. So in our first example here, I've got octane, found in gasoline, so C8H18. And combustion has to involve oxygen, O2. That's what we react with. That's like that riddle we had on our one riddle page. If I'm in a room sealed with methane gas and I light a match, nothing happens because there's no oxygen. Well, when I have complete combustion, that's the good kind, like in our furnaces at home. So we're going to make carbon dioxide and water. Incomplete combustion, it's still a hydrocarbon. Here we have propane, like in our tanks for our barbecue grills. We're still reacting with oxygen, but incomplete combustion is what we don't want to have at home with our furnaces, which is why we clean our furnace filters and make sure there's enough air going in so we don't make carbon monoxide, which is why we also have those detectors, and we still make water. So it's easy to predict the products of combustion. Complete is going to be carbon dioxide and water, incomplete carbon monoxide and water. And so for these reactions, just go ahead and balance them. So now pause the video and balance these two equations and finish writing and balancing the two synthesis and the two decomposition, and then check them. Restart the video and I'll show you the answers. Hopefully you've tried those on your own and you're not cheating, but here are the answers. These are the two synthesis reactions, aluminum oxygen making aluminum oxide, and potassium and sulfur making potassium sulfide. Aluminum being +3, oxide -2, that's why we have Al2O3. Potassium is +1, sulfide -2, that's why we have K2S. Decomposition answers. Magnesium is +2, oxide -2, which is why we just have MgO. Carbon tetrachloride, tetra is 4. And so when it breaks down into carbon and chlorine, Hofbrinkel, which is why we need 2 of them to make the 4. And then our combustion balancing answers. Both of them needed the recipe to be doubled. So with 2 of the hydrocarbons, I know the numbers get big, but that works out. I've got 16 carbon here, 36 hydrogen, and then 32 plus 18, that's 50 oxygen, which is why I have 25. And the other ones work as well. All right, so later we'll look at the single replacement and double replacement predictions, but that's all for now. Thanks.